Hello, Charles Fader here with Hanby Environmental. What we're going to do is we're going to demonstrate our water kit with a slight change. Normally, we use an extract solvent that's heavier than water, so it sinks to the bottom, and we decant that off to run our analysis. But instead, today, we're going to use a lighter solvent, a different solvent, that's going to float on water. So we're going to decant off our water sample prior to releasing our extract solvent to do our analysis. So with that said, let's get started. As it shows, the steps process here to our water analysis is we put our water sample into the separatory funnel, then we add our extract solvent, we swirl it around to do the extract. Then normally we would decant, then we put the separatory funnel back into the ring stand and our solvent separates the bottom, and we would decant that off into the test tube. But instead, we're going to do the same process, but we're going to put our water sample in, add our extract solvent, swirl it around. But before we do this, we're going to decant off the water sample because our solvent, in this case, is going to be floating on top of the water sample. Then the process is the same. We'll release the extract solvent into the test tube, add our white catalyst powder, cap and shade, and compare to the picture. So that being said, here we go. We got some water here. We're going to put in our water sample here. This is a 500 ml separatory funnel. There we go. We got our water sample in. Now, let's add our contaminant, which is some old gasoline. Here. And we are simply going to put in 1 drop of gasoline. Well, actually, we're not even going to put a drop in. We're just going to take our, we'll put 1 drop in. 1 drop. There. 2 drops. There we go. So we've got our contaminant in our water sample. And just to make sure, I can definitely smell it because I tapped it on the side there and some of it's stuck to the glass. Let's just go ahead and get that water put around in there and make sure that our contaminant goes throughout that water sample. Okay, so we got some contaminated water with some old gasoline. And now, instead of using our typical heavier water extract solvent, we're going to use our lighter high range extract solvent that's actually lighter than water, but it will do the same thing. It will do the extraction. We will just have to add that additional step of getting rid of the water sample prior to releasing the extract solvent into our test tube. So we're agitating our water sample to do the extraction, moving that extract solvent throughout the water sample to the extraction. And now we're going to let it settle so we can see some separation between that solvent and that water. The solvent should separate and be floating on top of the water. We can start seeing a layer start to develop here on top of the water, which is our extract solvent floating. See the separation layer, but we're just going to give it a little bit more time just to make it more prominent. Let's see from your side if you can see the layer. Yeah, you can see the layer right there separated out on top. So that being the case, let's decant off this water sample. Get rid of the water so we can utilize that extract. So we're going to release this water out. starts coming down to that tapered, we should start to see the solvent getting thicker as we release this water, so that's good. It makes it more prominent so it's easier to see. So we're getting rid of that water, so you can see it's getting thicker and thicker because of the tapered portion. Now we wanna, so right here, we can still see there's a little bit, this is the water right there. We wanna make sure we get all that water out to the point we let a little bit of solvent go through, because that solvent is what we're interested in, and we wanna make sure we don't have any water. Now, that being the case, I let a little bit of solvent come through to help clean out this stem, but just to make sure, we are going to go ahead and take a little piece of paper towel here and make sure that stem is dry, because we want to make sure we don't have any water, because as we release this solvent through into our test tube, in fact, we're going to release just a tad bit more, because we know we've got 10 mils of solvent in there, and we only need 4.2 mils of it, so we're going to release a tad bit more of it, just to make sure we see solvent has come through to help us make sure there's no water in that stem. And again, we're still going to take the extra precautionary step of taking some rolled up paper towel and sticking it up in this stem, drying it out just to make sure, double sure that there is no water here, because that solvent will push through that water into our test tube, and we don't want that because it'll react with our catalyst powder. So we want to make sure this is dry. Do it again. Just to make sure that it's completely dry up in there. Okay, as luck would have it, of course, I would come to do this and forget to bring a test tube with me. Okay, back. Now, we are going to deal with our test tube. There's a black scribed line on the test tube which represents 4.2 milliliters. We're going to release our extract solvent up to that scribed line. Okay. Okay, then add our white catalyst powder to our extract to develop the color. And as soon as the white powder hits the extract, it should pop color, because we know that our sample had gasoline in it. Okay, as you can see, that solvent is no longer white. As you can see, it's no longer white. Obviously, we can just put it right up to the book right there and see that the book is white, and this against the white background is no longer white. Now, we are using what is called our high range extract solvent, which we typically use in soil. So we're not using our typical extract solvent for water, so we don't want to use our water calibration. Since we use our extract solvent that we use in soil, we want to use in our high range soil, we want to use our high range calibration. So as you can see here, our high range is in percentages. So as opposed to ppm, our high range solvent, which is a weaker solvent, we where 1% is 1% of a million. 1%, if it was that color, would be 10,000. Likewise, 0.25% would be 2,500, and 0.05% is 500. And as we can see, we're more in line with that 500 ppm, if not even a little bit less, in between the blank, which just represents 0, and the 0.05% of a million, which is 500. So, as you can see, utilizing our high-range extract solvent will work for extracting from water. It's just we have to do that decanting step of our water sample to make sure that we don't get water into our test tube before we add our anhydrous or dry catalyst powder, because it reacts with water. It'll puff, smoke, and heat up, and that's not what we want. It'll hydrate our catalyst. So we want to make sure we get rid of that water sample prior to releasing the extract from that water into our test tube. So all we were doing here was demonstrating the fact that not only can we do that by using our high-range extract solvent to do a water, it requires that extra step of getting rid of the water sample. And then of course we're going to have to compare it to our high-range soil calibration book, which is based on using the high-range solvent, as opposed to comparing to our water calibration book, because the water calibration book uses a different solvent. It's much more sensitive, more powerful solvent, and since that's not what we're using to do our extraction, we have to use the other comparison. So there we go. We have it. You know, does it work? Yes. So now that the color is more fully developed, we can kind of see, and I'll bring it over there so you can see it closer. It's actually probably a little bit higher than that 0.05, or maybe it's right in it. But you know what? The good news is I have a mobile app, so we can literally snap a picture of this result, and our app will calculate the concentration level for us, put it in a PDF report that we can instantly share, and it's also stored for future reference as well. And the only person who has access to that is you. I don't have access to your reports. Only you do. So again, we would have to run it using the soil high range, since that's the solvent that we used, and that's the calibration book we would want to compare it to. So works. There we go.